our next session for the day. Our esteemed speaker, Mr. Viral Savla, is an instrumentation engineer with passion in process automation and control. He is founder of Proca Engineering Solutions LLP. Proca Engineering Solutions LLP is a focused end-to-end control and automation solution provider. Proca Engineering Solutions before starting Proca Engineering Solutions, he worked with various engineering companies on overseas assignments in Kuwait, Abu Dhabi, Qatar, and Singapore. So let's give a round of applause for Mr. Viral Savla. Thank you, sir.
Good evening, everyone. So, any one of you have heard about Industry 4.0 here? So, no one has heard about Industry 4.0, okay? So, government of India is talking about 5 trillion economy. And what is going to pull back us from this 5 trillion economy? So, what? Infrastructure. But government is developing the infrastructure. Skilled manpower, automation, okay. So biggest worry for the government is the manufacturing sector of India, okay. So if you say right now, if you go to any developed economy, okay, you ask a 2-year guy, 4-year, any guy who is maybe about 10 years, he knows what is Industry 4.0. But if you see within India, since we lag very much in the manufacturing sector, very few people know what is Industry 4.0, okay. So I'm here to just give an introduction to what is Industry 4.0. So before starting Industry 4.0, let us run through whatever the Industry 4.0 is nothing but the 4th industrial revolution. So let us see what were the first 3 industrial revolution. So we can understand well what is the 4th industrial revolution, okay. So first industrial revolution was when we made the first machine, okay. Instead of handicraft, we started use of machines, and instead of manpower, we started using the steam power from the steam, okay. So this was the first industrial revolution. Then came the second industrial revolution. So just a small slide on how the first, okay, then came the second industrial revolution. In second industrial revolution, what we did was, instead of steam, we went to electrical energy. So electrical energy was, I would say, it had less of a wear and tear, okay. It was quite compact, okay. Then another thing was, what we started doing was, we started with the mass manufacturing as part of industry revolution 2, as well as we started all the assembly lines. So what was the drawback of the first industrial revolution was that we only used to have a machine, and we used to only produce as a unit. So one machine produced today, next machine he produced today, just next day. So production was really very slow. In second industrial revolution, what we did was, we started mass producing the things. So if you would have heard of Ford Tesla T model, okay, that was the first, that was not the first, that was the second thing produced as a mass production. First thing was the cow slaughtering, which took place in USA. So that was unfortunately the first thing as an assembly production. Second was Tesla Model T. Then came the third industrial revolution. In third industrial evaluation, what we did was, now in production line, everything we started doing in assembly things, right? But still it was done by humans, okay. So now production was limited by the human efficiency and basically by the human efficiency. So let's say, for example, in assembly line, there are 500 people who are in that assembly line, and if 2 are not working properly, or they are not well that day, or something like that, so all the productivity of all the other 400 employees will go down, okay. So now then another thing was introduced was the machines which started assembling the things, okay. So just to give a gist of it, this is, you can see how robots are assembling the things. So this is a car manufacturing unit where robots are manufacturing the things. Okay. But now again, if you see these robots, now if you see the robots are pre-programmed to what needs to be done. So you can say they have intelligence, but very little, limited intelligence. Okay. Now when we talk about Industry 4.0, it's a high level of intelligence. When we say AI, we are expecting to robot think like how human thinks. Okay. So now let me give a gist of what is an example of Industry 4.0. So if you see here, there is again a robot here, okay? But now this robot has lot of intelligence built into it, okay? It is capturing lot of data and it is sending back to its factory, and a lot of data analysis is done. You can see this robot is also able to visualize the things and identify the things, okay? So this is what the next manufacturing is going to be, okay? So if you see articles, whenever there is a meeting or convention, okay, main thing what government says is we have missed Industry 1.0, we have missed Industry 2.0, we missed Industry 3.0, and now if you are going to miss Industry 4.0, okay, this would really take us back, okay. So government is trying to push a lot of things, but as we are more oriented with the service oriented businesses and not more of a manufacturing, okay, this is a worry for all of us. So now I'll just tell you what are the characteristics of Industry 4.0. So first is you would have heard about Internet of Things, okay. So Internet of Things is like, this is an example of we all know that everyone uses the gas supply from MGL, okay. So there's a gas distribution network. So can you tell me in gas distribution network what all things you know as a owner that MGL needs to monitor, that parameters? Pressure, leakage, correct. Consumption. Then damage, fire is there, okay. Gas leakage, okay. So all this, if you say they are measured from last 50 years, all these parameters are measured, okay. But these parameters are measured at local level. They are never collected at a centralized point, or they are not. They are measured periodically, maybe once in a week, twice in a week, or maybe if even they are measured every daily basis, but it is still at the localized station. So let's say, for example, there is a gas gathering center in Mumbai, another gas gathering center is in Nagpur, other is in Jamnagar. So the data was localized to that center only. It was never centralized, okay. So now what we have done is, what now new industry is doing is, they are making the devices or sensors which can directly transmit the data to the main data center. Second thing is autonomous robots, okay. So there are a lot of places. Right now we had a presentation on drone. They gave a very good examples that where human can't reach, there all these robots and drones would reach. So I won't go much deep into it. I think so it was well explained in the previous slide. So that is another aspect of the Industry 4.0, that you are going to use smart robots to collect the data. Then comes the big data. See, now you understand how much of a data has been collected. Maybe few years back, our mobile were only 2 GB, 3 GB of RAM of data. Now everyone would have been getting a message that your Google Drive of 100 GB is full, right? So in next maybe in past 2 years, if 200 or 100 GB of our data is already with Google, so how much of a data is stored in their cloud servers, okay? Similar way, now lot of data has been stored on the cloud server, okay? Now it is not about storing the data, but how fast you are going to retrieve the data, okay? Now this has been already enabled, okay? So now industry first used to only, let's say, measure pressure, temperature, some values. Now they are also continuously recording the videos. They can continuously record other parameters which are high data intensive, but still it can be stored and very fastly retrieved for the further processing. Okay. Then comes the cloud computing. Now, nowadays, if you see, we are using a lot of apps. Let's say even a single Google photo. When you are searching something in the Google photo, are they using your mobile? What do you say? Are they using your mobile processor? They are not using your mobile processor. They are using their cloud processor. And let me tell you, they are really very, very, very high-end processors. Okay. So now what has happened is, since you are able to very quickly transfer the data to and from your supercomputers, okay, so what Industry 4.0 is, whenever you want to do high level of analytics of your process or high level analytics of any of the manufacturing steps, you don't need to have a computer or a server in your premises. You can have a cloud computing by someone like Amazon or Google or Microsoft. Use their data to get your things processed. So that's really, and boon that you don't need to be capital intensive. Otherwise, buying one server would cost crores of rupees. Okay, but then you can lend it and do the cloud computing. Then comes the cyber security. See, now if you have seen, maybe before me there was one on cyber security already. So now there is a lot of awareness of the cyber security, as well as since now the data is not confined to our premises, it is going on cloud, it is coming back from the cloud. So cyber security is very active nowadays, and there is a lot of awareness and steps have been taken. And this is helping us to do this type of computation, of cloud computation. So cyber security is another element of this Industry 4.0. Now coming to additive manufacturing. Okay, so now we already had one presentation on 3D printing today. Okay, now previously what used to happen, no, we were not able to update our goods or update our products very frequently, because we had to maintain the spares, we had to maintain basically we had to maintain the spares and a lot of inventory. Okay, so now we have an additive manufacturing where even if I want to update my product, okay, and I am not maintaining the spares, I can print that spare and utilize it for my product which has been outdated. Or if there is some complex, let's say this is a turbine. If I want to make a complex product for my study or my research, we can use the additive manufacturing for the same. So this is one of the another element of Industry 4.0. So this is just an example that this was an old piece of a wall which was not working well. We 3D printed a new wall, okay, with better response. Then comes the augmented reality. Okay, so I think so everyone would have heard about Google glasses and Apple glasses and all. Okay, so now if you see in the industry, I don't need to go sit in the control room or understand what are my process parameters. Okay, as you see in this photograph, using the augmented reality, just displaying the screen in front of my vessel, I'll come to know what is the real-time data there. Okay, again, now with the augmented reality, I can replicate my process in a simulation form also. So if I have a new trainees or new joinees in my company, okay, I can train them on the augmented reality, so they are very, the learning curve for them is very less. Okay. Similarly, if you see this next slide, now here you can see a mechanic doing some troubleshooting. Okay, I don't need to be specialist for any equipment or any services in my factory now. Okay, what I can do is a guy with a basic knowledge can be employed there, and we can take a remote support from the specialist of that equipment or of that device. So this is how the augmented reality is going to be part of Industry 4.0. Then comes the digital twin. So this is one of the most important aspect of digital of the industry 4.0. When I say digital twins, so what we do here is, let's say I'm going to set up any factory right now, okay? I am going to make an exact replica of that factory in terms of how it is going to look physically and how it is going to work dynamically, okay? So even before I start my factory, using the mathematical modeling and using the digital tools, we'll come to know what are the pitfalls, okay? So this will reduce the go-to market for any manufacturer. Secondly, it is not, it's not the first time what model we are going to make is going to be perfect. There will be a huge data sharing between the digital twins, okay? So let's say, for example, I start a factory, I have a digital twin of that factory. My factory is running for 2 years. I will take that 2 years data into my digital twin and try to optimize my process, try to debottleneck my process and increase my productivity in that process. So this is all about digital twins, okay? And last but the most important factor in industry 4.0 is how we integrate our processes. So in industry 4.2, there are two factors. One is vertical integration, another is horizontal integration. In vertical integration means I can, from my vendor to my factory to my consumer, how well I can integrate my data, okay? So let's say, for example, if my vendor is shipping something, okay, and sending it to my factory, so via APIs I will come to know when my product is going to be ready, my feed is going to be ready, based on which I can do my production planning and further give my planning to my consumer, and he can do it further to their consumer. So this is called horizontal integration. And in vertical integration, if you see that how well I am going to send my data to the cloud computing or to history or to historians or for analytics, okay? So this is called vertical integration. So I think so this is all about technical things about industry 4.0. Any questions?
I am working for railways.
Okay.
In your video, I saw a robot maintaining the train.
Yeah.
So, what kind of time period you believe will be for us for having such technologies?
See, if you see time period, nowadays all these things have already started in industry. Okay.
I am not seeing anywhere in India.
See, in India, as I said, we are very slow in adopting the technology. Okay. But things are happening. You would have seen that railways till date their data collection and everything was at very ground level, right? Nowadays, lot of digital implementation is going on in railways. Okay. So if you say this right now, the high-speed rail which is going to come, they have started adapting the latest technologies. If you say the metro rails, they have already connected everything via Industry 4.0. That is, everything is there on SCADA. Okay, so maybe right now they are at Industry 3.0. Okay, but I believe high-speed rails, if they are not adapting Industry 4.0, they won't be able to maintain it because it requires high level of accuracy, high level of maintenance. Okay, so that is what still it is not implemented in India, but it has to be, and maybe if we have to be with the world, we have to implement it. If you see in oil and gas industry, in chemical industries, already a lot of things have started being implemented. It will come to railways also. Okay, thank you.
Thank you so much, Mr. Viral Savla, for this insightful lecture. From 1784, from the looms to this current scenario of 2024, we have come from industry of point 1 to point 4. So thank you so much. I would like to request Mrs. Hemali Gala to felicitate Mr. Viral Savla with a token of thanks. Please give a round of applause, everyone.